Very good afternoon to everyone. So just want to share a little bit about vibration analysis. Right, so at this moment for us in the plant maintenance area, we are trying to get additional certification or additional competency for our lecturer. So before we do that, we have to understand a little bit why do we need that. Vibration analysis is one of the area that we can explore through the professional certification, whereby there are about, I think it's 4 certification from category 1 to category 4. So what is vibration analysis? So vibration analysis in maintenance is defined as the process of measuring and utilizing the vibrational wave produced by the machinery in order to gauge the health of various parts of the machine and predict when it might need maintenance or replacement. So when part of the machine is getting what we call in the way to be defected, so might as well it will produce some defect, whereby one of the method that we can use is to measure the vibration. All machines vibrate, from the simpler appliances in your home like ceiling fans and washing machine to more complex machinery like the wind turbine, heavy equipment in a factory, or even turbine-driven water pumps at nuclear power plants. Okay, the time between vibration and the frequency with which they occur can tell us a great deal about the machine's condition. Okay, so it's not, it's still in the way or method for condition-based maintenance. So the vibration analysis can find such faulties as imbalanced bend shaft, faulty bearings, improper alignment, gear failures, or cavitation in pumps. And since the measurements are taken while the machine is operating, there's no need to open it up or conduct time-consuming internal inspection. What does that mean? So we can do the measurement, or we can do the analysis without stopping the operation. All right. So how does vibration analysis work? Remember that high school math class you struggle to pass. You wonder why anyone in the real world would ever need a graphing calculator, or how they might use the formula and equation you are being asked to utilize to solve problems in the real world. As vibration analysts, we use those equations and graph every single day. We have to determine what are the reading that are being shown by this equation or the graph that we get from uh, the vibration analysis. We use accelerometers, lasers, and other tools to monitor the vibrational wave patterns coming from engines or pumps, bearings, fan blades, shafts, or other part of heavy equipment. Then we use those patterns to make prediction on when the machine might break down. While the maths and calculation are fairly complex, the process is pretty simple. We connect our monitoring equipment to various locations on a given machine and monitor its vibrations over time. The data we collect is then fed into the software that performs the calculation we use to provide detailed reports on the current condition of the machinery. For example, think of a fairly simple machine like a ceiling fan at your house. Okay, when you first install it, it spins beautifully and is whisper quietly, very smooth, without any harsh sounds. But over time, it begins to develop a noise. Maybe after 1 year or 2 years, start to develop a noise. It clicks once every time it rotates. Okay, there's no sound of click, click. Okay. There are no visible signs anything strong. You cannot see it by your visualization. Okay, just a slight repeating click. As more time passes, maybe another 2 or 3 years, the click gets louder and you begin to notice a slight wobble. Okay, the fan is starting to wobble. Now the click is accompanied by a thumping sound of the fan moving as it wobbles. Whoop, whoop, whoop. Okay, harder sounds. A few weeks later, the screws holding on the fan blade that were never quite tightened all the way down when the fan was constructed come completely loose. Okay, we didn't realize it before, we didn't visualize it before, but the screw loose. Then the fan blade falls to the floor and the fan other blades dig grooves into the ceiling as the fan continues to rotate. you are left with plenty of repair work to do to fix the fan and the damage its failure caused. Now remember, sound is a wave. Okay, each of those clicks and thumping sounds at the fan just now are made has been made and can be monitored and analyzed actually. And even before you notice that sound that were loud enough to get your attention, the loose screws in the fan blade made noise and created wave as they move and loosen every time. If you have paid the attention to those sound earlier, those waves, those vibration, you have fixed the fan long before the blade detached and long before the fan's failure caused significant damage to your home and the fan itself. So it goes the same to all the equipment in the industry. Why do you need to analyze the vibration? As said before, okay, just you have to predict the failure on a ceiling fan by paying attention to the vibration it produced earlier. You can predict the failure of heavier industrial machinery by paying attention to the vibration those machines produce. Okay, especially the machine that have been running for quite some time, and then why is it important? Can you just do the routine maintenance to make sure your machine all lasts as long as possible? Okay, if you do the routine maintenance is one part, or you wait for the machine to fail or run to fail is another part. Then routine maintenance is important. So you can't run a car without oil, and oil breaks down over time. So we change the oil every 3,000 miles. To make sure we are not potentially jeopardizing the health of the car's engine. But that is a routine servicing that we are doing. But if you knew the exact state of the oil in your engine at the very moment, exactly how well it was doing its job at the moment, from 1 minute to the next, you could wait to perform that routine maintenance until you have gotten every possible mile out of your oil. More miles per oil change means money saved. Yep. So this is one of the method that is important in scheduling your maintenance. So this is what what I've told to the students before. This is very important for you to enter the industry. Okay, one of the method is by vibration analyst to make sure that you can know or you can predict how long does it take to run the routine maintenance. Okay, so as I told before, you have to compare if the manufacturer of the machine or the equipment or the motorcycle, okay, state that you have to change the oil every 600-mile round trip or every 3,000 kilometer or 5,000 kilometer run. Is it true? Why not you do your own risk potential or your own test at the machine or at the motorcycle, okay, by using this vibration method to see whether is it really you have to change the oil at the stated kilometer run, or you can prolong it to make sure that you can save the money for a longer period of time. So the same concept applies to heavy industrial machinery. Knowing that the exact state of well-being of the machine allows factory owners to schedule maintenance as often as it's truly needed and not on a schedule based on abundance of caution. So with the data that you collect from the vibration analysis, you can predict earlier how long that this machine needs to be maintained, or how long this machine or this component will fail through time. So vibration is one of the method where we can save the operator's time and we can save the money by providing information of the health of the machine from the vibration analysis. All right, so thank you. Just want to share it today. What is vibration analysis? And remember, there are bodies that can provide training for vibration analysis, vibration analyst, monitoring and analyst, category 1 to category 4. Okay, it will cost some amount, but then it's very important if you have that certification, the competency certification, added certification. That means you are going to be a very important man in the industry when you graduate from here. Okay, thank you very much. Okay, see you.